Hi, in this video I'm going to show you, I'm going to talk about what is polynomial, how do we find the degree of a polynomial, what is the leading coefficient, leading term, domain and graph of a polynomial, okay, and then I'll give you some examples on that. Okay, so the polynomial is any function that has the exponent of x, or the variable exponent must be 0 or positive integer, okay, 0 or positive whole number, the exponent. So it should have of the form like f of x equals to a sub n and then x sub n, meaning that this is the highest degree term. So n is the exponent, highest exponent, and then a sub n minus 1, an minus 1 are the numbers, and then x to the n minus 1, and then so on up to a sub 0, right? It should be like that because the last one is the constant, okay? So this is a polynomial function. There is no x in the denominator. All the exponents are whole number and they are positive or 0, okay? So if like you have like x to the negative 1, it is not a polynomial. If you have x to the 1/2, it is not a polynomial. So the exponent must be either 0 or a whole number, a positive whole number. That's the polynomial is. But these numbers can be anything though. Those numbers can be anything. We'll see that later. Okay. How do you find the degree of a polynomial? Degree of a polynomial, first of all you decide whether it is a polynomial or not. If it is a polynomial, then we go to the degree, leading term, leading coefficient, like that. If it is not a polynomial, we don't have to worry about all those things. Okay, so once you know the polynomial, this is a polynomial, then the degree is the highest exponent. In this case, the degree is n. So degree is basically the highest exponent. Okay, when we evaluate a degree, if two of the x terms are multiplied, or if there are factors, what you do is you find the degree of those factors separately and then you add at the end, okay? For example, if you take like x minus 1 times x squared plus 2, this is a polynomial because the exponents are all positive integers, positive whole numbers, right? But what is the degree? How do you find the degree of this? So here the degree of the first one, the exponent is 1. For this first factor, the degree is 1. For the second factor, the exponent is 2, right? So the exponent is basically 2 here, meaning that the degree is 2, degree is 1. So what is the total degree? It will be 1 plus 2, that the total degree will be 3. This is one way of finding the degree. Other way is you FOIL this, okay? If you FOIL this, you will get x cubed plus 2x minus x squared plus minus 2, right? So what is the highest exponent? So it is 3. So the degree is 3. All right? So the leading term is the term with highest exponent, okay? So in this case, so the term with highest exponent, meaning that here this is the term with the highest exponent, right? So it is the leading term. Here this is the term with the highest exponent, so this is the leading term, okay? Now the leading coefficient is number or the coefficient of leading term, meaning that, see here, this is the leading term, right? The a sub n, that's the number that is multiplying the x to the n. So this is the leading coefficient. In this case, the highest degree term is x to the cubed, right? And what is the number? What is the number multiplying x to the cube? Or what is the coefficient? This is just basically 1. So here, the leading coefficient is 1. The domain, so for any polynomial, if it is a polynomial, the domain is all real numbers. Or in other words, you can write negative infinity to positive infinity. That is the domain of any polynomial. The degree could be anything, any whole number. So the domain is always between negative infinity to infinity, okay? Now the graph of any polynomial function is smooth, okay? So graph will look like this for any polynomial function. But the polynomial function cannot have graph like very sharp corner like this, or a cusp. What do you mean by cusp? It is like this. So if the graph has like very sharp corner or cusp, sometimes a graph can be like it comes up to here and then there is a gap and then go up to there like that. So it cannot have a gap. The graph of a polynomial function cannot have a graph, has a gap, cannot have a gap, and also it cannot have a hole there. Okay, if a graph has a sharp corner, a cusp, a hole, or a gap, then it is not polynomial. It is not the graph of polynomial function. Not polynomial function. It is a polynomial. Okay. All right, let me take this example. So here f of x is x cubed minus 2x to the fourth minus 3x squared plus 5. So can you tell me what is the degree? So degree is the highest exponent, that is 4. Okay, so what is the leading term? So here leading term is the term with the highest exponent, that will be negative 2x to the fourth. That is the leading term. What is the leading coefficient? So leading coefficient is basically the number that comes in the leading term, that is negative 2 here, right? Basically the number that multiplies the highest exponent of x. So basically it is negative 2. So what is the leading, so what is the domain? So domain is always all real numbers from negative infinity to infinity. Okay. The next one is this function gx equals to 3x squared x minus times x minus 1 times x squared plus 5. So what do you think the degree would be? Because if there are the factors multiplying each other, then to find out the degree, what you do is you find the degree of each of the factor and then you add at the end. That will be the degree of the whole polynomial function. Okay, so here the degree of the first part is 2, the degree of the second factor is 1, and the degree of the third factor is 2. So 2 plus 1 plus 2 will be total degree is 5. Make sense? So how about the leading term? What do you think the leading term would be? So leading term is the term with the highest degree. What you do to find out the leading term is you FOIL that first, or sometimes without FOILing we can find out that. So when you FOIL this and that, you will get x to the third, right? That will be the highest degree term on this product. But we will have to multiply by 3x squared. So it will be like x cubed will be the highest exponent here. So x cubed times 3x squared, that would be 3x to the 5, right? Because the total degree is 5, so there you will see x to the 5 anyway there after when you FOIL. But here there is 3 multiplied, right? So it will be 3x squared times x squared. So you just multiply the highest exponent only, and you will get 3x squared times x squared. That will be 3x to the 5. And what is the leading coefficient? So leading coefficient is just 3. That multiplied the number that multiplies x to the 5th. Okay. So what do you think? Is hx is a polynomial? It is not, because x to the 1/2. The exponent of x is not a whole number, so it is not a polynomial. No, not a polynomial. Also, how about the last one? It is not a polynomial because there is x in the bottom, right? Because the domain will be all x except negative 2. But if it is a polynomial, the domain must be all real numbers. The domain of this is not all real numbers, right? So it is not a polynomial. Since x is in the denominator, it is not a polynomial. So the answer is not a polynomial. Since it is not a polynomial, then you don't have to worry about whether this polynomial has degree. What is the degree? You don't have to worry about all those things.